Hi. One of the most fun parts about Python is the Python turtle graphic. You can actually using Python to do some simple graphic. Um, and Python come with a simple graphic called turtle. And the basic turtle program consists of these lines here. I want to show you using PyCharm how this program work and see why we want to using a turtle. So let's me start the PyCharm here and let me do a Python file. Let me call this turtle. Let me call this turtle 1. I will have a few more turtle. First thing you want to do is the import turtle. We talked about module before. Import turtle, import the turtle module. This will allow us to use the turtle library. And you need to create a screen and turtle dot screen. Let's do incremental development. Let me just do like a couple lines at a time. And in order to hold the screen, I want to add loop here, put a main loop. This statement here will hold the screen. So let me run this. And here's a screen. This is a turtle graphic screen. Nothing in it right now, but yeah, I create a screen. So let me close this. So I can add a turtle. I name the turtle Alex. So the turtle name Alex. And if I run that, all you're seeing is an arrow. And which direction is the turtle pointing? By default, it pointing to the east. And you can have the Alex the turtle move say 150 pixel or 150 unit and turning left 90 degree and that move him another 150 unit, actually 75 unit. And let's run this and you can see he moved to the right because pointing to the right initially 150 unit and then make a left which is counterclockwise rotation 90 degree and move forward 75. So with the turtle graphic you can do write it like interactive code. So I already talked about this. Take a look at the book for more of the turtle method. And do you recall which direction does the turtle face when it is created? If we recall, it facing the east direction. How to draw a triangle, how to draw a square, and how to create many instances of turtle. First of all, you can create many instances of turtle by creating more turtle, like task is turtle dot turtle. So I have a turtle named task and task dot left 180 degree. So instead of pointing to the east, I can have task pointing to the west, and I can have a task say forward 200 unit. And let me run this here. So this is what it looked like after I run that. You have two arrows for two turtle. It may look kind of confusing with the turtle, what you're seeing here right now. But we will look at how to make the turtle with a different shape. You can use a simple for loop with the turtle. If I want to draw a say a square, I can using a turtle to draw a square. So let's try that out. See how that works. Let me call this turtle2. Get a new file. Import turtle in order using the turtle library. Create a screen. These are all pretty much statements that you need to do in order to create a turtle. So I get the screen. I create a turtle named Alex, and I can have the turtle move in a loop. Say Alex start forward 50 unit, and he turn left 90 degree each time. Instead of using main loop, I can also have something called exit on click. When I click on the screen, that's when the turtle exit the program. So here is a turtle with a square. If I click on the screen, that exit the program. That's what the wn.exit on click does. And we talked about the iteration before using list, and it's better to use a range. And I can change this to, say, range 4, and it should work the same way. I create a turtle and draw a square, and I can make a bigger square. Let me run this. Now I have a bigger square. Right. Here's some more useful turtle method. Pen up. By default, the turtle tail is down. So if when the tail down, that's when you draw the line. You can use pen up and pen down. Pen up, the tail will be up, so it will not draw a line when you move. And then you can do pen down and then forward to draw the line. You can have a turtle shape. So like an outer dot shape is a turtle, and you can use in color also. So if I come back to say the pie chart, the two turtle I created earlier, if I say outer dot shape is turtle, same thing for task dot shape is turtle. There's few of them, and to make things simple, I can also set their color. Alice is green, and task is let's just say blue. And if I run the turtle one, now you can see two different turtle with two different color. One is Alex and one is Tess. You can also do speed control. Alex does speed. 1 is slowest, 10 is the fastest, and 0 you turn off the emulation. Alex does stamp. The stamp method, you can stamp the footprint onto the canvas as the turtle move. You can look at the turtle documentation in the book as well as on the web for more information about the turtle. So let's write a program that draw a hexagon with a length of 100 units. Earlier, we did a square. This turtle 2, we did a square. how should I modify this program? And for this matter, I want to show l.shape is turtle. How should I draw a hexagon using this program? When you look at the algorithm, a lot of time you look at a simple algorithm and you will try to update to make it work for for the program. In this example, this one draw a square. Why you draw a square? Well, one of the main things you draw a square because you repeat it 4 times, and each time it turn 90 degree. If I have a hexagon, so let me draw a hexagon here on this page. So if the turtle goes forward this much, how much he need to turn over here? How much did he need to turn? Well, in the hexagon, well, in the square, you know, he turned 90 degree. In the hexagon, um, well, actually, let me turn the hexagon left, which is this way. That's how I would draw the hexagon. But how much you turn is the same thing. How much do you turn here? Well, if you look at the hexagon, I have 1, 2, 3, 4, 5, 6 equal angle here. And how much of this angle? Well, there are 4 triangle here, and each triangle have 180 degree. So 4 times 180 is 720 degree, and that's a 6 of them. Divide by 6. So that means each angle here is 120 degree, and that means this angle will be 60 degree. So if I look at my turtle, I would turn 60 degree and repeat that 6 times. I should be able to draw a hexagon. And right here is a hexagon. What about a decagon, a 10-sided polygon? So if you have a 10-sided polygon, again, you need to look at how many degree. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I have a 10-sided, how many triangle I can draw from this 10-sided? If I have 6-sided, it's a 4 triangle. For the 10-sided, that means 8 triangles. Why is it important? 8 triangle, 8 times 180, and then using my using the Python shell, h times 180. So that means the total number of degree inside the triangle is 144, 1440, and that's a 10 side. That means each angle is 144, and that means I need to turn 36 degree in this case. So if I want to create a 10-sided decagon, I would turn 36 degree. And let me make the screen bigger because now the shape is bigger than the screen here. Let me make the shape bigger. So here's a 10-sided polygon. And let me make the length smaller so I can fix it in the screen. Let me rerun this. and you can see this tensile here. Now think about this here. How would I create any side polygon? Think about how do I create. If I want to change this program, I will leave that up to you, and create any side polygon, like for example 20 side, 12 side, 15 side, or 5 side. How would you rewrite this program such that it can create any side polygon? Think about how I just do the calculation to see if we can write a program to create any side polygon. Thank you.